So let us spend some time talking about how can we extend the fundamental Ohm's law to tackle any kind of circuits that we encounter in real life. Let us recap very quickly what Ohm's law was all about. So let me just quickly make sure that we have the right. So Ohm's law essentially states that the voltage across a closed circuit is equal to R multiplied by I. V is actually measured in volts, R in ohms, and I, which is the current, in amps. Now, we can actually extend this basic principle to a large variety of circuits. Take, for example, we have a circuit which is in serial. So we have a resistor R1, we have another resistance R2, and we apply a voltage V across this simple circuit. When we apply, we have a current which is flowing in this direction, and basically what we land up is this is voltage V, the voltage at this point is V1, and then the voltage at this point presumably the same as this, which is 0. If we apply the Ohm's law, what we get is V minus V1, which is the voltage across this circuit. This is the circuit that we are talking about, is equal to R1 I, and V1 minus 0 is equal to R2 I. And if we solve this equation, we essentially get V is equal to R1 plus R2 into I, which can be represented by R effective for serial circuits into I, which means that when we have two resistors in series, the effective resistance of that circuit becomes equal to the sum of the individual resistors. Two things that you must remember. The voltage at this point, V, falls to V1 at this point. This is the other point. So assuming this is A, this is B, and this is C. This is the voltage at A, this is the voltage at B, and then across the resistance it falls to C. So the voltage as we measure across will continue to fall, but the I, or the current, remains constant. When we look at the other type of circuit, which is known as putting resistors in series, we get a slightly different situation. Out here, the I actually gets divided amongst the two resistors into I1 and I2. The voltage across A and B, that means across these resistors, remains the same. So, as opposed to a situation here where the voltage was falling and the current remained the same, in this case the current is actually changing. It changes across the different ones and the voltage essentially remains the same. So we apply that the I is equal to I1 plus I2. I can be written as V, or effective for parallel circuits, is equal to V upon R1 plus V upon R2. Then we come up with the other formula, which is V effective parallel is equal to 1 upon R1 plus 1 upon R2. So this is one formula, and the other formula that we see is here. So what we will now show you is how to use these two basic